All right, section 10.4, we're going to be taking a look at measures of central tendency and variation. This phrase, measures of central tendency, you've probably heard that described as averages in some fashion or another. So we're going to look at three specifically, different types of measures of central tendency. The first one is the one that you are most familiar with. It's the mean, also called the arithmetic mean. It's the quote-unquote average of the values. It's found by adding the values together and then dividing by the total number of values. So some variation of this is probably what's used in all of your classes, whether it's adding all your points together and dividing by the total number of points, or adding your test values all together and dividing by the total number of tests, something like that. So that's the mean. We use this one a lot. The mean can tend to hide things, though. So, for example, I had a class that I just graded a test for, and in that class, several students got some really low grades on their test. But they'd been doing really, really well up to that point, exceptionally well. So that low grade added in there didn't really seem to affect things all that much. But clearly it means that there's something going on that's different than what was going on before. So sometimes the mean is not the best way to figure out what's actually happening. So another measure of central tendency is called the median. The median is the middle value. It's found by listing all the numbers in numerical order. If there's an odd number of numbers, there's always a middle value, right? Like if you have 3 people, you put them in height order, there's always someone in the middle, right? But things are weird when there's an even number of people. If I had 4 of you and I put you in height order, there's no real middle, right? Because there's 4 people. So what you do when you're working with the median, if there's an even number, is you take the 2 elements that are in the middle and you average those. So in my height example, I would take the 2 people who are in the middle of the group of 4 people, and I would find their heights and I'd average those 2 heights together. In a traditional mean sort of value system, you add them together, divide by 2. The median value is a nice mark. It tells you the 50% mark. It tells you half the people are above this number, half the people are below this number. Whether that number is height, whether that number is grades, whether that number is the weight in a box of cereal, right, the average number of ounces, the median weight is the 50% mark. Half below, half above. The last one is mode. Mode is the number or numbers that occur most frequently. And while it may not always make sense to use, there are times when it does make sense to use. So imagine a company where you have almost everybody making around $30,000. And then there's the president of the company and he makes $3 million. Totally just made these numbers up, but just pretend for a moment. It wouldn't make sense to average those numbers in a traditional fashion, right? Most people don't make the 3 million mark. So throwing the 3 million in would actually vastly affect the mean in a way that's not appropriate for what's going on for the most data values. So there are times when looking at the mode is more appropriate. Another example, and I hope I'm not spoiling a homework problem, but I remember it coming up and I don't think it was in the homework, talks about clothing. So when you're looking at clothing in a store, if somebody's wanting to decide how many pieces of clothing of certain sizes to purchase or whatever, what they really want to know is about how many people in each of those size categories might want that particular item, right? So the items that are sort of flattering for someone who's very thin, you might actually order many more of them in a very thin size because that's the mode, right? The most people who are going to purchase that item is in that category. Whereas for something that's, whatever else, you might order it in a different. Hat sizes, I think, is an example in your book that talks about this, right? You want hats that fit. Okay, well, I don't really care what the average person's hat size is. I want to know what the majority of people's head sizes is. That's a mode thing. So we can use the mean, median, and mode for any set of data. That's fine. It just doesn't always represent what's really going on equally well. It just depends on the data set. So the first thing we're going to do is just a data set that doesn't have any context, no real meaning behind it. It's just a list of values. Okay? So we're going to find the mean, median, and mode for these numbers. We'll just go in order. So as I'm writing this out too, I hope that you're thinking about what I'm writing down, because sometimes it's easy on these to sort of skip some steps along the way. The problem with that in general is that there's two problems. Number one is that if you get the right answer and you don't show me any work, I don't know that you didn't just, copy it from the back of the book or from a neighbor or something like that. That's not super helpful. But more detrimental to you is if you did it right, but you just had a typo in your calculator. That'd be nice to know so I can give you partial credit instead of just saying, well, clearly they don't know what they're doing because they got the wrong answer. So show me a little bit of work along the way, and I'll show you what I mean by that. So we're going to do the mean first. I want to use that color. Let's use black. So one thing that you could write down, and it's a good thing to do, especially because there's only a few values here, is that the mean is actually just adding all these values together. And then dividing by the total number of values. So how many values are in this data set? There's 7. So by writing that down, I know that you're doing the right process. Then if you typo in the calculator and get the wrong sum on top, we'll know that that's the problem. So if I add these values together, 18 plus 22 plus 22 plus 17 plus 30 plus 18 plus 12. I have 139. Did y'all get 139 as well? Wonderful. And if we divide by 7, this gives me 19 point, and we'll use 1 decimal most of the time with everything in this section. If it tells you to do something different, of course do that. But if it doesn't tell you, we'll just go with 1 decimal, so 19.9. Okay, so that's my mean. My median. So when I'm doing my median, what I want the middle value. So the way that I show the work for that is that I need to put the numbers in order. You can do smallest to largest or largest to smallest. It doesn't really make any difference. I kind of tend to go the smallest to largest ordering on things. So 12 is my smallest value. And as you're working, if you want to sort of make a line through them just to make sure you've caught them all, you don't miss something along the way, you can. So I have 12 and then I have 17. I have 2 18s. And then I have 2 22s and a 30. Okay, is that all right? This is an odd number of values. That's the easiest way for this to show up. If there's an odd number of values, I have a middle value. What is my middle value? 18. It's 18. So this 18 right here would be my median. So this one's 18 for the median. 19.9, whoops, for my mean. And then my mode is the number or numbers that occur most frequently. And you might notice that I said or numbers. So if there are multiple numbers that occur the same most number of times, you can have things that have more than one mode. So if you have 2 modes, it's called bimodal, for example, right? Like bipolar or bicycle or biannual, right? 2. So when we're looking at mode, on this one, we do have 2 modes. What are the modes on this one? Yeah, 18 and 22. So there's no like averaging or anything like that going on with modes. You simply list whichever one's most frequent, or if there's more than one there, the most frequent number of times you list them both or all 3 or something. If all of your values are the same number of times, like everything occurs once or everything occurs twice, then we say there's no mode. That's the only time we say there's no mode. So just because there's multiple things isn't a problem, but if there's nothing that repeats or everything repeats the same number of times, then we have no modes. So this one is bimodal. All right, let's take a look at a couple of examples that do have context. Example 2 says the mean score on a test set of 20 tests is 75. What is the sum of the 20 test scores? Now, I didn't quite write this out in words, but we talked about it. Our mean takes the sum and it divides by the number of values. So imagine you wanted to know what your average test score or quiz score or homework score is in a particular class. You add all those scores together and you divide by the number of those scores. So in this scenario, we don't have the sum and the number of values. We have the mean and the number of values, right? So we will enter those values into the locations where we have them. And for this one, we have 75 as our mean. And our number of values is 20. And it should make sense that if on average the test scores were 75, and I want to know what the total number of scores are, what I really need to do is I really just need to multiply the test scores times the number, the test score 75, times the number of test scores, which was 20. And if you multiply 20 times 75, you'll get, wow, that was not a good number, 1,500 points. That's my sum. We don't usually do it in that order. But I bet that you've utilized Canvas's tool where it says, hypothesis, pretend if I get this on this score, what will be my average in the class? Have you guys utilized that before? It's using an algorithm something like this. It's taking what you have and it's putting some random scores in intermittently into its search engine, right? What if you get this? What if you get this? What if you get this? And so forth. And it's spitting back out to you. You'll get an A or you'll get a B or something like that. In particular, another thing that you can do with this is that if you know what your scores are, and you'll have an example in the homework or the group work, I can't remember, maybe both, and you know, say, 4 of the 5 scores, right? You just know 4 of them. You can figure out what your 5th score needs to be so that your overall average is an A or a B. And you can do that using this idea as well, and we'll encounter that one in a minute. An example of that, though not with test scores, is our last example for today, example 3. This is talking about a football lineup. The mean weight of 7 linesmen on a team is 230 pounds. The mean weight of the 4 backfield members, 190 pounds. What is the mean weight of the 11-person team? Now, if they were the same number of people in the 230 category and the 190 category, you could just add the 230, 190 and divide by 2, but they're not. There are more people in the 230 weight category than there are in the 190 weight category, right? So there's got to be some sort of a balancing to what's going on there for that to work. And this is like your weighted averages in your classes where somebody's looking at there and they're like, I don't understand, I have A's in everything except that one test. Okay, but the test was worth 50% of your grade and everything else combined was only worth 50% of your grade, right? There's a weightedness to it. It's worth more because it's got this category value. The same thing's happening here. It's worth more if you're in the linesman category because there's more of you. That's it. So we still have the same sort of description I did over here where it's the mean is the sum divided by the values. So my mean is still my sum divided by my number of values. And I do, in fact, have 11 people. So my denominator is for sure 11. But what happens on top is what happened over here on the left-hand side. I have the number of scores, in this case the number of people, times their overall average. So, right, if I wanted to figure out, if I took those 7 linesmen, and I multiplied by 230, I could find out how much they weigh in total, which might be useful if they're getting on an elevator, right? That's how the elevator does the weight limits on their categories, right? So this kind of an operation is what they're thinking of. I'm taking an average number of weight and I'm multiplying it by an average number or the number of people at that weight category. And then I have 4 people in the 190 category. So 7 times 230, because there's 7 of them that weigh on average 230 pounds. 4 times 190, because 4 of them weigh on average 190 pounds. This is sort of the minimum that I would expect that you would write down, is this right here. You don't necessarily have to write my equation at the top, but this you'd write down. And then if you want to use your calculator to let it just do the rest of the calculation, that's totally fine. If I'm working with this to the nearest 1 decimal, what will this give me? Do you have it, Kaylee? Yep, 215.5 pounds. It's always a good idea to make sure that sounds reasonable. First of all, the value better be between the 190 and the 230, right? Well, yeah, it better be. I'm averaging something somehow, right? And it needs to be closer to the 230 than the 190 because there's more values in the 230 than the 190. And this fits that criterion well. So it may not sort of verify that it's for sure correct, but at least it's in the right category for it to seem reasonable. Any questions on that? Right, that's where we're going to stop today.